All right. Good morning, good afternoon. How we doing today? We got our first flip video of the year, of the season. It's a big day today. Um, this class is going to be entirely flipped. All right. So you will have a video to watch every night, or most nights when you go home. When we get back to class, we'll do a warm up. Okay, we'll do a warm up over the material that you learned the night before, and then we'll practice the material that you learned before. So really, you're hitting it 3 times. Um, you're hitting every single piece of material 3 times, which is great practice for you. Hopefully, they say what's that old saying, like third time's a charm or something. Well, hopefully that's the case here. Okay. Today we're just kind of introducing pre-calc. Okay, you're going to hear a lot of terms that you may have heard before, all right, in your previous math classes, okay. All right, so if you look on your packet, okay, at the beginning it says topics to prepare for pre-calculus. Now, I'm not going to go through all these terms, okay. These are a lot of things you've already seen before, okay. For the sake of time, we'll only allow 15 minutes for each video. So for the sake of time, sometimes Mrs. Logos or myself will have these definitions and terms here for you. So we'd like you to read over those terms. We're not just doing them for our own good, even though we love these terms. Okay, hopefully someday you will too. All right, but make sure you read through a lot of these things just for this first day. Okay, adding and subtract with unlike denominators, adding and subtracting fractions with the like denominators, equivalent fractions, rules of signs, or things you've seen before in your geometry classes, and advanced algebra or what have you. Okay. We talked about multiplying fractions, we talked about dividing fractions. So this is kind of what we're going to talk about today. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, and at the end we'll wrap it up with real numbers. All right, so let's flip it. So we're on the back of that first page now, okay, where it says Unit 1 video. All right, today's learning targets are to understand the real number system, okay, what the real number system is, the different types of real numbers there are, okay, and different subsets within it. The first one we're going to talk about are natural numbers. All right, so I know this is kind of scrunched, so I'm going to try to write small because I know you don't have a lot of space, so I won't write too much. Okay, but the first type of numbers that we're going to talk about, the first subset that we are going to talk about and discuss are natural numbers. Okay, natural numbers are counting numbers. Counting numbers. Think about when you learn back to when you were younger, when you learned to count, what'd you use? The numbers you can count on your fingers, okay, on those fingers. It's our smallest subset within our real numbers. So in this box, okay, throughout the year, we're going to ask you to pause the video. So I want you to pause the video and write down the counting numbers or the natural numbers that you see here, the ones you can count. Pause it, pause it, pause it. You should have gotten 1, 3, 12, and 503,456. Those are our natural numbers. 1, 2, 3, and this big giant, oops, fourth one there. Okay? Again, please pause, go back, rewind if you have. That was confusing, okay? The next type of numbers we're going to talk about are whole numbers. So whole numbers are natural numbers, so all the numbers that we list prior, okay, they're counting numbers you can count on your fingers. So the natural numbers and you include 0. And you include 0. So it's all the numbers you can count on your fingers, plus the number 0. So why don't you write down all of the whole numbers from this list, in this box. All right, pause it, those whole numbers. So the whole numbers that I got were our natural numbers from the time before. Plus 0. There you go. plus 0. Let's make that red. Boom, 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 boom. All right. Okay, so let's talk about integers. Okay. You ready for this? So integers are our next subset each time we're talking about these numbers. So this is our smallest subset of real numbers. Okay, this is our next smallest. This is our third. So this is like our small, our medium, our large. Okay, so these types of integers, they're natural numbers, whole numbers, and negative natural numbers. Wow. 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 Okay, so our negative natural numbers, so this includes, so we're including our first subset of natural numbers, then our second subset of whole numbers, then adding our negative natural numbers. So why don't you pause the video, okay, and yes, and write down your integers. So here are, keeping the colors the same, all right, my natural numbers are in blue, okay, whole numbers, negative naturals, all right. So each time we talk about a different subset, we're going to increase in size here, okay? Yes. So let's talk about rational numbers next, okay? Rational numbers next. Now, rational numbers, we've talked about rational numbers before, all right? You've talked a lot about rational numbers. Look at this in the word rational. All right, let's see. Let's get that highlighter going. Booyah, here we go. So we got this nice word right there, ratio. Now remember last year, if you had me last year, or whoever you had in geometry last year, there was a big chapter we talked about, or throughout the entire year, we talked about ratios. The ratios of angles, the ratios of sides. Okay, so remember we said ratios where it could have been 3 to 2. We write it like that, or 3/2, okay, when we talked about similar figures as well, there was a lot dealing with ratios. All right, so a ratio is essentially, we're comparing two things. We're comparing the size of two things. Well, list all rational numbers and describe their subset. Well, they include every single number we talked about before. So they include natural numbers, because natural numbers can be written as a fraction. Okay, they include whole numbers, and they include integers. So rational numbers are numbers that can be written as a fraction. So numbers that can be written as a fraction. All right. Sorry, sometimes you're gonna have to get used to my handwriting here. Okay, trying to write on this screen with this little thing, it's not the best. All right, but so all of our natural numbers can be written as fractions, right? If I think about the number 1, I can write it as 1/1. If I think about the number 3, I can write it as 3/1. I could write it as 12/4. I could write it as 9/3. Okay, those can all be written as fractions. All right, so let's look at our set of real numbers here. Okay, I want you to pick out the numbers that can be written as fractions. Now, there's some obvious ones, and there's some not so obvious numbers here as well. All right, so go ahead and pause the video and write those down. All right, let's knock out the obvious ones here. -7/3. Okay, and I'm also going to include 3.14 and 0.01231. Okay, now you're thinking to yourself, whoa, dude, what? How is 3.14 and then this is plus all the rest as well, and the numbers from the previous subsets. So -7, -1, 0, 1, 3, 12, and 1 million. So all of these, -7, 0, 3, 12, 1, -1, right there. So those all are also included. Let's go back to this 3.14. And you're thinking, well, isn't that pi? Well, pi, that's not pi. That's sometimes what we abbreviate for pi, right? Pi is 3.14159, blah, 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 off into infinity. Well, 3.14 is an actual finite number, okay? 3.14 can be written as a fraction. How? Well, this is our hundredths place right here, right? So this is technically, if I wanted to rewrite this as a fraction, I could divide it, put it over 100 like that, okay? Because this is our tenths place. If it was 3.1, I could put it over 10. I could put that number over 10, which would be 31 over 10, okay? But it's our hundredths. So if I want to move the decimal place 2 spots, this way 1, that's 10, 2, that's 100. So to move the decimal point 2 spots, I just put 314 over 100, okay, which would give me, if I want to reduce it, 157 over 50. Same thing here, okay? I have one, I apologize, had a little crisis to take care of, okay? But anyway, let's get back to our discussion here. This number here, okay, we have 0.0123456 Okay, that's a lot of places. Well, that means I move the decimal place 1, 2, 3, 4, 5, 6, 7 times. So really, I could do 1 over 1, 1, 2, 3, 4, 5, 6, 7, like that as well. And now, if you're like, what the heck are you talking about? Okay, where did all this come from? All right, an easier way to do this, okay, would be to plug this decimal, 3.14, into your calculator and press math, enter, enter. Okay, same thing with this one. 0.000001, plug it into your calculator, press math, enter, enter to get that fraction mode there as well. Okay, so you are not coming up with your own fraction. Okay, so anyway, rational numbers, remember, numbers that can be written as a fraction. Okay, well, irrational numbers, all right, you guessed it, are numbers that cannot be written as a fraction. Okay, they're decimals that never repeat or end. Buckets. There we go. You'll have to excuse my spelling and handwriting. It's been a while. Okay, decimals never repeat or end. Okay, yeah, exactly. So if you look over here, well, the only two irrational numbers you're going to see are the square root of 5 and pi. Those are our only two irrational numbers in this subset, okay, or in this set of real numbers here. Okay, well, we're talking about a lot about these things called real numbers in general. All right, real numbers, I'm just going to write a little note down here before I run out of time. Real numbers, I got like 30 seconds. Real numbers are not, they're all numbers, but they're non-imaginary numbers. Non-imaginary numbers. Remember, our friend I equals the square root of -1. That's an imaginary number. So any number that's non-imaginary. All right, so that kind of wraps up the first video. All right, I hope you enjoyed it. Many more to come. Adios.